This essay discusses the hows and whats of ethical hacking, pen testing, and general stages during an engagement. For in-depth documentation, please see the links and references in the associated Adobe Acrobat PDF file. This contains large amounts of resources for the minutiae of ethical hacking, along with training and certification courses. Introduction. In our rapidly changing digital era, technological advancements are at the forefront of societal progression. New platforms and technologies, from cloud computing and Internet of Things, IoT, to artificial intelligence and machine learning, continually emerge and evolve. While these developments offer unprecedented opportunities for innovation, they also present new avenues for potential security threats. Each technological evolution introduces a new layer of complexity to our digital infrastructure, making it increasingly difficult to maintain airtight security across all aspects of a network. Every new device or software integrated into a system can present potential vulnerabilities that malicious hackers, also known as black hat hackers, may seek to exploit. The persistent nature of vulnerabilities and the need for ethical hacking. Despite significant efforts from organizations and cybersecurity professionals to secure networks and data, vulnerabilities can and do persist. These vulnerabilities might result from simple programming errors, misconfigurations, or lack of security controls. They may also stem from the rapid pace of software development, where the pressure to deliver functionality often takes precedence over security. This constant state of vulnerability underscores the necessity for ethical hacking. Ethical hackers, also referred to as penetration testers or white hat hackers, serve as the first line of defense against potential security threats. They use the same strategies, techniques, and tools that a malicious hacker would employ, but in a controlled, legal, and ethical manner. To pursue a career in ethical hacking, a strong foundation in computer science is beneficial, often obtained through a bachelor's degree. Gaining early career experience in network support or engineering and obtaining professional certifications like CompTIA Security and EC Council's Certified Ethical Hacker (EH) can enhance employability. While not always required, a master's degree can provide a competitive edge in the job market by equipping candidates with comprehensive knowledge and practical skills. The ethical approach to hacking. Ethical hackers aim to identify and fix vulnerabilities in a system before they can be exploited maliciously. Their role is not to cause harm, but to enhance system security. This differs from black hat hackers, who break into systems with malicious intent, such as to steal data or cause disruption. Ethical hackers operate with explicit permission and respect privacy, while black hats act illegally. Ethical hacking also differs from standard software testing. While developers perform unit and integration testing to identify bugs, ethical hackers focus on finding security flaws that could allow external attacks. Ethical hacking provides a holistic assessment of system security, simulating real hacking techniques. This proactive approach improves overall security and helps address vulnerabilities before criminals can exploit them. Ethical hacking also provides valuable insights to help strengthen defenses across the software ecosystem. The findings allow developers to create more secure code and prompt security patches for known flaws. Certified ethical hackers often have technical backgrounds in areas like computer science, programming, or network engineering. Hands-on experience in IT administration, system configuration, or security operations is also common. Many pursue certification programs like the Certified Ethical Hacker (CEH) credential from the EC Council to validate their skills. Ongoing learning is essential in this rapidly evolving field. Part 1. Understanding ethical hacking. Ethical hacking is a highly complex field, requiring broad technical expertise across many domains. White hat hackers must have in-depth knowledge of operating systems like Windows, Linux, and Unix to understand how they function and their potential vulnerabilities. Proficiency in networking protocols and concepts like TCP/IP, DNS, and routing is essential to identify flaws in network architectures and communications. Programming languages like C, Python, Java, and Ruby are important to analyze source code and find bugs that could be exploited. Database skills in SQL, NoSQL, and others allow ethical hackers to spot weaknesses in data storage and retrieval. Web application languages like HTML, PHP, and JavaScript enable finding flaws in web apps. Knowledge of cloud platforms like AWS has become crucial as well. This expertise allows ethical hackers to model the sophisticated techniques used by black hat hackers. For example, in the 1990s, hackers like Kevin Mitnick leveraged social engineering and phishing to steal data. This prompted security experts to adopt similar techniques ethically to test defenses. In the 2000s, malware attacks emerged as major threats, spreading through emails, websites, and unpatched systems. Ethical hackers adopted malware code analysis and reverse engineering to combat this. As hacking techniques evolve, ethical hackers must continuously expand their knowledge. Understanding the tools and techniques used by black hat hackers or malicious hackers is a critical part of an ethical hacker's knowledge base. This includes knowledge of various hacking tools, understanding different types of malware, and being familiar with different tactics used in social engineering attacks. Equally important as technical expertise is a strong ethical foundation. Ethical hacking's legitimacy stems from operating with permission, within legal limits, and adhering to principles of minimal intrusion and non-maleficence. Ethical hackers must always ensure they have proper authorization, scoped by contracts, before attempting any intrusion activities. Unauthorized hacking crosses legal and ethical lines. Respecting individual privacy is also paramount. Ethical hackers must never access or share more personal data than necessary for testing purposes. Any sensitive data uncovered must remain confidential. Findings should always lead to strengthened security and fixes, not exploitation. Companies often implement incentive programs to encourage responsible disclosure. Ethical hackers must avoid pursuing personal gain or public recognition from their discoveries. Upholding ethical principles has helped distinguish constructive security research from criminal hacking. However, ethical gray areas remain, like selling unknown vulnerabilities. The common thread is acting with integrity as a white hat professional to secure systems against real-world threats. Adhering to codes of ethics is as crucial as technical know-how. Penetration testing, the heart of ethical hacking. One of the primary methods employed by ethical hackers is penetration testing, also known as pen testing. Penetration testing is a simulated cyber attack against a computer system, network, or web application, intending to uncover exploitable vulnerabilities. Penetration testing, or pen testing, is a simulated cyber attack against a computer system designed to identify and exploit vulnerabilities. This process is crucial for enhancing the security of web applications and is often used alongside a web application firewall, WAF.